Hello, everyone. So I just want to briefly go through the code for the difference in difference class that we were not able to go in detail. So let me just pull up the context so we can talk a little bit about that. So as you can see here, we're going to be talking about the Taylor Swift example. So we already saw in much more detail the kind of 2x2 difference in difference example, where we're just comparing kind of West Coast to non-West Coast states before the album was available for everyone. And now what I wanted to do is just look at the entire data set that we have. So in this case, as you can see here, we have three different groups. Non-West Coast states actually received the album right here, right? So a bit later in time. West Coast, because of the glitch that we were discussing, received the album earlier. So again, you can see it right here with this peak. And then we have two different kind of fictional states that did not get any new releases from Taylor Swift. So as you can see, basically their popularity is a bit lower, but it does seem to move kind of parallel to the other two. Okay, so we're going to be working with this whole data, and let's see how that looks. Let's go to our studio. Great. So again, I'm just going to be loading the data set for Taylor Swift. So as you remember, we basically just have a panel data of states by week. So you can see here that this is each state with the date for each week. An important thing to note is that date is actually a string variable, so it's a character. So it's not considered exactly as dates for our studio. So we will need to tackle that as well. We also have a measure of popularity. This is our outcome, right? And then we also have two different dummies that we're going to be using. West Coast, it's basically a binary variable that takes the value of 1 if that state belongs to the West Coast and thus received the album earlier because of the glitch, and 0 in another case. And in the case of controls, basically this is just a 1 for those two fictional states that do not receive the album at any point. Okay, so you can think about this as kind of always pure controls because they're not treated at any point in time. So this is the first part that we already saw in class, where basically we just ran a 2x2 diff and diff before the album was released for everyone. But what I wanted to look at now is actually the effect for the other states as well. So for those that were treated early, meaning the West Coast, and those also that were treated later, meaning the non-West Coast. And again, we're going to compare those to, in this case, those weird states that never received the album. So the first thing I'm going to do, and I don't want you to get too caught in this, but I will need to transform my variable, my time variable, in this case, dates, into a numeric variable. So I'm going to generate a new variable that's called week, okay? So first what I need to do is tell our studio that dates, that variable, is actually an actual date, so they consider it as such. And again, it has kind of an order in that sense. So that's what this function does. So as date basically is telling, I'm sorry, our studio that dates is actually a date, right? Not just a string. Then, because these are weeks, and again, for simplicity purposes, I actually want to format them just as weeks, meaning what week in the year is this? So what this does basically is just format the different dates and just assign it a week number. Okay, so for instance, if this was the date was January 1st, it would assign a number of 1, right? If it's, I don't know, January 24th, probably would assign a variable of 4, right? So again, it's measuring basically the number of week in the year. Okay? So that's what this is doing. And again, I want to treat this as numeric. So let's see what this basically does. So let's run this Swift. And as you can see, we have week here. And again, the week of the March 1st is the 8th week of the year. The next week is the 9th, 10th, 11th, and so forth. Okay, so that's just what this is doing. Again, don't get too caught up on this. I usually will give you just the numeric variable for the period. But it's also important for you to see how this can be done. Great. Another thing that I do need to do as well is basically transform the IDs for each state into a numeric variable as well. And this is mainly because the function that we're going to be using in the DID package requires all these things to be numeric. Okay. So what I'm going to do is remember that state is just a character variable. So we can see here is Alabama, Alaska, Arizona, etc., etc. So first I need to transform it to a factor. So what is this going to do? It's basically going to change from a character to assign a label and an actual numeric value to that. Okay. So that's what it's going to do. And when I just transform it as numeric, it's going to transform that factor variable into an actual number. Okay. So I don't really care that much what those numbers mean. I just need a numeric variable that kind of identifies each state. So let's run that. And as you can see, state numeric now is 1 for Alabama. It's going to be 2 for Alaska, 3 for, I think Arizona comes next, and so forth. So great. We're kind of tackling this format problems first, and we're going to get to the good stuff now. Great. So the other thing that I'm going to need in order to run my function is actually identify when the different states are actually treated, meaning in which week in this case. Okay. So as you remember, the West Coast was treated on the week of July 19th, right? So I'm going to assign for all those West Coast states, I'm going to assign the number of the week that it was actually treated. And as you can see here, I forgot, oh yeah, there we go. It's the week 28, okay? So as you can see here, the week of July 19th in 2020 is the 20th week of the year, okay? So if you're in the West Coast, I'm going to assign you just for everyone number 28, because that again is the week that you were treated first, and 0 in any other case, right? So we created this week treat variable, which is great. Again, it just captures the week that the West Coast states were treated. But remember that the non-West Coast states were also treated at some point, okay? So we also need to incorporate that variable, right? So I'm just going to do another if else, and again, just mutate the regular variable that I just created, week treat, right? And for everyone that is not in the West Coast and at the same time is not one of those two weird states that never received the album, right? I'm going to assign a new variable, a new value of this, right? That is going to be the week of August 9th, because that's when the album became available for everyone, okay? And as you can see, that week is week 31, okay? So, and again, for the rest, I'm just gonna leave the same assignment that I had before. So the West Coast keeps its number 28, and the control group just keeps its number 0, okay? So let's just quickly create this. Great, so as you can see, Alabama was not in the West Coast, so it was treated on week 31. If we see, for instance, let's just view this so we have a better idea how this looks. So for instance, if we go to, let's go to California very quickly. There, California, as you can see, it was treated on week 28. So it has a 28 for every value. Arkansas, on the other hand, has a value of 31. Okay, so that's basically what we just created. So now basically we're ready to use this function att-gt from the DID package. And again, it's always a good idea if you're not familiar with the function to just kind of see what this is doing and what the different arguments mean. Okay, I've included them here, but the main thing that we need is first the outcome. And again, this is like the name of the variable, so you need to write it between quotes. So here's popularity. We also need basically the time variable in the sense that the treatment is going to be introduced at some point in that dimension. So in this case, my time variable is going to be week. We have a panel in this case. Remember that states are kind of grouped, right? So we see each state a different week. So the name for each individual cross-section or each individual state is given by now state numeric. And finally, gname, it's a variable that indicates when the different states were actually treated. So again, remember that this just takes 3 values, 28 for the West Coast states, 31 for the non-West Coast states, and 0, meaning that they were never treated for those weird kind of states there, right? And my data is just my Swift data set. So let's just run this. Don't worry too much about this warning messages. It's basically telling us that we do have kind of a small control group. That is fine in this case, but let's see what this gives us. So the first thing that we can do is actually get the summary of this DID object. Okay, so let's just see what this does. And as you can see, we get a huge table. Okay, what this is telling us first, group 28, this means that is showing us the average treatment effect for the different weeks here in time, right? For the groups that were treated on week 28, meaning the earlier groups, the West Coast states, okay? So as you can see, this is the estimated average treatment effect on the treated, okay, for the West Coast states on the first, basically, time period that we can see, right, week 1. Then for week 2, for week 3, etc., etc. And as you can see, basically, we get the whole 51 time periods. Okay. The same thing for the now non-West Coast states. So again, we get that for group that was treated on week 31, right? We get all the different effects for each different week, right? And of course, we get not only the estimated ATT, but also the standard errors and the confidence interval. So this is great, so we can see whether these effects are significant or not. But again, this it's kind of cumbersome to actually look at. So let's just look at a plot of this, which I think is much more interesting. So let's quickly just run. It's called ggdid. Again, it's kind of a play of ggplot and the DID package. And again, we just apply it to the DID object that we created. So let's zoom a little bit on this. Let's see if we can actually see this one. There we go. So as you can see, basically what we get here is 2 plots. For group 28, remember that that is the earlier treated group, the West Coast states. And then for group 31, which is again the late adoption group or the non-West Coast states, right? So as you can see, the actual West Coast states received the album like 2 weeks earlier, right? That's why these are green a bit earlier than these ones, or I don't know, turquoise or something. All of this basically is all the effects that we can estimate before actually any intervention happened. So you can think about all these basically as placebo test, and this is great. We would like all of these to actually be 0. So remember that this is estimating kind of an effect on an intervention that did not happen in any of these periods, right? So we would like to see everything kind of around 0, and as you can see, there's a few that are kind of significant, but at the same time, they seem to be kind of all consistently around that 0. So this is actually a great placebo test, and we can see that overall, it seems that in the pre-intervention period, parallel trends are holding, okay? For week 28, when the West Coast state was actually treated, you can see a huge bump, right? And this is basically, again, the average treatment effect on the treated for the West Coast states on week 28. And as you can see, that effect actually starts kind of dying down a bit when we move forward, meaning that popularity probably spikes a lot just when the album is released, but then that effect kind of dies down a bit. And we see a very similar pattern with the states that were actually treated later, right? So again, kind of all sort of centered around 0. So again, this is kind of this is a good sign, especially like right here, right before the intervention was set in place. You can see that this is very, very close to 0. So that's great. Pre-trends seem to be holding. in terms of being parallel. And again, huge jump on week 31, which is when non-West Coast states were treated. And as you can see, the same thing that happened with the West Coast, this kind of starts dying down a bit after time passes. Okay, so this one, in this case, would be the estimated average treatment effect on the treated for the non-West Coast states on week 32. Okay, so this is the great idea or the great thing that actually we can see with the DAD package. So it is very easy actually to implement staggered adoptions of a difference in difference approach. So again, you don't need everyone to receive the treatment at the same time. You can actually have treatment being introduced at different points in time. And with this DAD package, you can very easily estimate those effects over time as well and do it in a correct way. It does take a little bit of manipulation beforehand. As we can see here, we do need to transform certain variables into numeric and things like that. Most of that I will give it to you so you, again, don't spend too much time doing that data wrangling. But the main idea, again, is to correctly interpret, especially this kind of plots, okay? So that gives you a lot of information, and hopefully this makes things a bit more clear, okay? If you have any questions, please also let me know. I'll be happy to answer any further clarifications that you need.